Okay, this lesson begins the next set of notes on probability models and measures of central tendency. And at the time of this recording, what I'm thinking is this is going to be broken up into 3 different video lessons, which means that the lesson should be pretty short and they're only going to cover a certain amount of notes. You will not need to upload those notes to Focus until after we have completed the entire set of notes for probability and measures of central tendency. So this is for the academic year 2020-2021, and the uploaded notes would not be done for probably 3 videos, but I will let you know at the end of the last video, and you should be able to tell from your packet of notes that you have finished this particular lesson. So we're going to start with a discussion of a fair game and the sense of what we mean when we use the word fair. So we have fair game or fair decision. It just, I guess, depends on the context. We all have this intuitive idea of what it means for something to be fair. And usually that idea of what we think is fair kicks in when we believe something has been unfair. So we definitely recognize something that's not fair when we see it, especially if we are on the receiving end of the unfairness. When we're talking about fairness mathematically, though, we mean something very, very specific. So if we're talking about a fair game or a fair decision, what we mean is this. We mean when all of the outcomes have an equal chance of occurring. So on your next test or on a multiple choice test or anywhere where you're asked about whether or not something is fair or to explain whether or not something is fair, you need to come back to this definition and reference it. So you would say, yes, it is fair because all of the outcomes have an equal chance of happening, or all of the, rolling a die is fair because each side has an equal chance of coming up on top. Or you would say it is not fair because here's where something isn't equitable, where you don't have the same chance of something happening. You can't go back to your sense of fairness and whether something is morally right or wrong, because that's not what we're talking about when we're talking in math class. Not that those things aren't important. It's just not the topic when we're dealing with it mathematically. So we have a couple of examples here. Is this a fair way to decide who will bring food to the class potluck? Okay, so we're going to have a class potluck back in the era where we could all sit in a room and eat together, unmasked, standing over open plates of food, talking to each other as though we weren't in a pandemic, okay? So here's the first way. We're going to have a class potluck, meaning people in the class are going to bring in some food and we're all going to share it and eat it. We're going to have a party in Algebra 2. So have all the students, that should be plural, students, have all the students line up in a row alphabetically. So I'm going to put you guys all in a row. The teacher goes down the line and flips a fair coin for each student. And the first 3 students to get a head bring in food. So I'll let you think about that. Remember, if the question is it fair? Then what you want to think is, does everybody in the class have an equal chance of bringing in food? All right, now hopefully in your head you've arrived at some decision there. Now what you might see in the phrasing of this is that the teacher is flipping a fair coin, and that's meant to be a bit of a distractor. The coin is fair, so when the coin is flipped, that means there is an equal chance that the student will get a head or a tail. So we go to the first student, we'll say, Ms. Adams, okay, is the first person alphabetically. And we flip the coin. Now here's where it gets dicey. The first 3 students to get ahead are the ones that are going to bring in food. So Miss Adams has a 50-50 chance of bringing in food. And then we move to Mr. Bear. Should do this on the fly. Mr. Bear. So, and then Mr. Bear has a 50-50 chance of bringing in food. Now, by the time we get to Mrs. Zebra in the class, chances are we have not made it that far. And so most students, when we talk about this in class, will say that this is not a fair way to choose who's going to bring in food. Now, if you're asked to explain it, though, you need to go back to that definition of fairness. And we would say no, because students near end of the line, okay, have less chance to be picked. Okay, like I'm not really crowding out my screen here. Okay, so if you're down at the end of the alphabet, chances are we are going to hit the 3 heads before we get down to you. So, and that's a much more complicated probability question. Probability does get very, very complicated. Like how many would you need to get through before you had probably gotten 3? I think the answer to that would be 6 on this. So if we had 6 people, that's when the probability tips that we've already had 3 heads. So I guess by the time we get to the 7th person, then the chances are that we're not really going to get past the 7th person. We might not get past the 3rd person. If the first 3 flips are all heads, then, we're done. And certainly by the time we've gotten to the 15th person in the class, it would be really weird if we only had 2 heads out of 15 flips of a coin. And so you get that sense that this is not fair because not every student has an equal chance. And you want to be specific. The students at the end of the line have less chance of getting picked than the students at the beginning of the line. Now, the next situation there, which you can't really see the bullet point anymore. Hopefully you can on your copy. Hand each student a card from a deck of cards. So I've got a deck of cards I got 2 decks of cards, and I'm going to give every single one of you a card. And we're going to do that like randomly, just like, in fact, it doesn't even need to be random. Using an identical deck. So I give all of you guys a card from the deck. The teacher draws at random, cards at random until 3 students have matching cards. So right now, the biggest Algebra 2 class I have this year, 2020-2021, right now I think is at 36 students. Actually, I think both periods 6 and 7 this year are sitting at 36 students right now. And so we wouldn't use all the cards in the deck. There are 52 cards in the deck. So we'd have some cards left over, and it could be that the first card I draw, nobody has that card. But eventually, I will start drawing cards that match the cards. And that drawing is being done randomly. Draws a card at random. I'm looking for a different color. At random until 3 students have matching cards. So my deck of cards, we're going to shuffle it up, get it all nice and scrambled, and we're going to draw those at random. This would be an example of a fair game or fair decision. Yes. And then if you're asked to explain it, you would say because all students have an equal chance to be chosen. Equal chance. That's supposed to be the word chance up there. I don't think that's any better. Okay, so when you're asked, especially for me, when you're asked to explain this, you do need to evidence that you understand what it is that makes something fair. So you can't just say yes or no with this like blind guess. You have to be able to explain it in terms of the definition. Now, one way to make fair decisions is to use randomly generated numbers, hence the title of this particular lesson. So one way to make fair decision is to use randomly generated numbers. So you'll notice that there's a question there, just with it followed by the words class discussion. So do you think it's easy or hard to randomly list numbers on your own? I'm going to pause for a moment and let you think about that, whether you think it is easy or hard to randomly list numbers on your own. Now, as you're thinking about that, hopefully you've arrived at a conclusion. What I often do in class then is I will actually have students start listing random numbers. And so students will start shouting out numbers and they'll say 3, 4, 2, 10. And then somebody realizes that we're missing some stuff. So somebody will say 150. Okay, so what they're noticing is that these numbers seem to be all kind of clustered around together. And so they're like, oh, we gotta choose something else. Now that right off the bat makes it not random because you're intentionally choosing a different kind of number, which means that the number 5 is no longer equally likely to be chosen because now we're intentionally trying to spread the numbers out. Then somebody will get on that boat and they'll say, oh, what about, 10,000? We were really big. And then sometimes in class, students will say, oh, wait a minute, what about negative numbers? We haven't even thought about negative numbers. And so without really paying attention, students weren't thinking about negative numbers, which means that they were not as likely to be chosen. It actually wasn't random. And then the moment you intentionally try to pick other numbers, now it's really not random because now you're looking at the set of numbers and thinking, what don't I have? And so people at this point, they're not going to pick 5 and 6 because they feel like, oh, that's too close to what we already have. Occasionally somebody will start going with decimals or they'll start going with fractions and stuff like that. Once in a while, somebody will throw in an imaginary number and say, okay, well, if we're really doing, random numbers, like we need to cover everything. And the point of that is that it's actually not easy for us to generate random numbers. In fact, sometimes we think random numbers should be evenly spread out. So if you had, say something like this, that if you were picking points at random, they should be evenly spread out. But the very fact that you're trying to make them evenly spread out means it's not random. So if you feel like you've got too many points clustered in here, you might say, oh, well, I got to pick something, outside of there. Well, no, not if it's random. If it's random, every point should be equally likely. So when it comes to generating random numbers or trying to do stuff in a truly random way, we really need to rely on something outside of ourselves. We won't pick things randomly. We are hardwired to look for patterns and to express patterns in the way that we think. So one of the ways that we can generate random numbers is to use something called a random number generator. And these are often computer-based programs that actually can be programmed to be legitimately random. Graphing calculators are equipped with this. So if you have a TI, and my Casio that is sitting to my right as I'm recording this, I short a battery in it and I haven't bothered to replace it. I'm pretty sure the Casio also has a random number generator on it. But if you have a TI 8384 and you hit the math button and then go over to where it says PRB, you'll notice that number 1 under that option is rand. That's random. Now, I often will usually use random INT, which is random integer, when I want to pick students randomly. So I will assign everybody a number, and maybe those numbers go from, say, 1 to 36 if there are 36 students in the class, and we will, and I'll limit it. So I'll say pick randomly, but pick an integer between 1 and 36. So in this set, pick randomly. So graphing calculators are equipped to do that. Sometimes random numbers are given on a list, and they will often be grouped into chunks of 4 or 5 for easier reading. So this that you see in your notes is a table of random numbers that was generated possibly electronically. And you'll notice that it's grouped into, what are these, chunks of 5. That the chunks of 5 is just to make it easier for you to read. So you're not looking at this continuous list of numbers, which can make it very easy for you to lose your place. Same reason like telephone numbers and stuff, like they're chunked. Okay, so that you're not just trying to memorize like a string of numbers. Not that people memorize phone numbers anymore, but so there's a class activity here. What I am going to do though is to just show you how it works. So we might do this activity actually in class. So suppose I want to choose 3 students in class to share their warm up with everyone. So we do some kind of warm up in class, and you're going to come up to the board and you're going to display your warm up for the class. So listen as I assign each of you a number. Usually when I do that, I do it alphabetically. And you would write your number down. Now we're going to look at this these numbers, random numbers from the book. Okay. Now, we'll use 1 through 36. So we'll pick one of the bigger classes. If you are in a smaller class, you would obviously have smaller. We would be picking from a smaller pool. So here's how it works. And we're going to go through just the mechanics of it, and follow as I do this, because you will have to use the table on your test. You are going to have to use the table of random numbers and come up with the randomly generated numbers. So you want to make sure that you're following along with how I do this. What we're going to do is use groups of 2 digits until we find 3 that match the number three that match numbers in the class. The reason that we have to use 2 digits is because some people in the class have 2-digit numbers. So if I look at this first row and I use single digit numbers, then we have 8, 7, 4. Well, that means that the student who's assigned number 8, the student who's assigned number 7, and the student who's assigned number 4, they are the 3 that are going to get picked to do their warm up. The problem with that is that now it was no longer random, because people from 10 and higher had no chance that they were going to be selected. And that's not random. So what we need to do is we need to take 2-digit numbers. So watch as I do this. So I look at that first line, and what I'll often do with different preps, just to make it more interesting for me, is like in period 3, I might use the top row of numbers. Period 6, I might use the second row. In period 7, I might use the third row, just so I'm not dealing with the same numbers all the time. So, but since none of you have done this before, we'll go with the top row. The first number that I see is 87. Well, none of my Algebra 2 classes have 87 students, so nobody is assigned that number. So all I do is I move on to the next one. The next number would be 49. I'm not really seeing that. So we have 87, and then we have a 49. I don't have a class of 49 either. Now, remember that the break in the chunk is just for us visually so that we don't lose our place. So the next 2-digit number is going to be 43. You're just going to kind of go right across the chunk there. Still, we don't have 43 students in the class. Next number is 97. Still haven't come up with a student to put their warm up on the board. But finally, I get 07. And that's going to correspond to student 7. So that's how you get your single digit numbers when you're picking the double digits. So student 7 is going to be the first student to put their warm up on the board. Next 2-digit number is 20. Well, all of my Algebra 2 classes have at least 20 students. So the student with the number 20 is going to be the next student to go. And we just keep going through. So we have student 20, then we have student 52. We don't have a student 52. Bridging the gap across there, we have student 59. Nope, don't have a student 59. Then we have student 57. No, still no joy. Then we get student 4. And there's our third student. And that's how you go through the list of random numbers. So what might be a good exercise for you to do right now, just to make sure that you know how to do this, is go look at the second row down and repeat the process for the second row down and figure out from the numbers 1 to 36 which 3 students would be picked. And then if you really want to practice it, do it for row 3 as well. So pause the video and then go through it and see if you can figure out which students would be picked with the second row and with the third row. Okay, if you went ahead and did that, just so you can kind of check your work and make sure that you're doing it correctly. Row 2, you get 2 of them right off the bat, 14 and 16. Like immediately we get 2 students whose numbers we can pick. Then we have 41, 58, 88, none of which would correspond to a student, and then 24 would be the third number. Row 3, if you went ahead and did row 3, something kind of interesting happens in row 3 that's worth us noting. For row 3, we start with 61, then we have 24. 24 would work as a student. Then we have 90, 82, 41, all too big. When we get to this third chunk, though, we get to 16. So there's our second number. And then we get 24 again. Now, if this were, like, depending on the context, maybe you could do 24 again. But if this is students that are going to put their warm up on the board, I've already picked student 24. I don't want the same student to actually put their warm up on the board twice. That's a waste of their time and ours. So what we would do is we would jump over the 24, and that would bring us to 31, and that would be the third student to go to the board. Whether or not you take the number more than once, that depends on what it is you're trying to do with the numbers. So there might be cases where you would take the number more than once, but not in the case in context of a student putting their warm up on the board. What would be a awesome test question is to ask you to do the same thing with row 4. All right, so that wraps up the first lesson on probability models and measures of central tendency. Fill out the notes as far as we have gone, but you do not need to upload them for the 2020-2021 school year unless I have given you some instructions otherwise.